This is a video from the Exam 3 review, and we're going to look at problem 7b. Suppose we have the summation from n equal 1 to infinity of n plus 1 squared divided by n times n plus 2. So this is equal to the summation from n equal 1 to infinity of n squared plus 2n plus 1 divided by n squared plus 2n. Now, let's take a look at the limit as n goes to infinity of n squared plus 2n plus 1 over n squared plus 2n. What I want to do is I want to factor an n squared out of the numerator and an n squared out of the denominator. So what I get is the limit as n goes to infinity of n squared times 1 plus 2 over n plus 1 over n squared divided by n squared times 1 plus 2 over n. Now, the n squareds cancel, and what we're left with is the limit as n goes to infinity of 1 plus 2 over n plus 1 over n squared divided by 1 plus 2 over n. But as n goes to infinity, 2 over n goes to 0, 1 over n squared goes to 0. So those all go. And what we get is 1, which doesn't equal 0. And so the summation from n equal 1 to infinity of n squared plus 2n plus 1 over n squared plus 2n diverges by the test for divergence. But if we look above, notice how these two series are the same. The summation from n equal 1 to infinity of n plus 1 squared over n times n plus 2 is the same as the summation from n equal 1 to infinity of n squared plus 2n plus 1 divided by n squared plus 2n. Those are the same series. And so therefore, the summation from n equal 1 to infinity of n plus 1 squared over n times n plus 2, that must also diverge. And that's how we do 7b. 7c. Suppose we have the summation from n equal 1 to infinity of 3 over 5 to the n plus 2 over n. Now, I'm going to look at the summation from n equal 1 to infinity of 3 over 5 to the n. This is equal to the summation from n equal 1 to infinity of 3 times 1/5 to the n. This series converges by the geometric series test because the absolute value of r is equal to 1/5 and 1/5 is less than 1. And oh, by the way, if we look at the summation from n equal 1 to infinity of 3 times 1/5 to the n, this is the summation from n equal 1 to infinity of 3/5, right? I'm pulling out a 1/5. And then I'm going to take 3/5 times 1/5 to the n minus 1. Now, this is 3/5 divided by 1 minus 1/5. Remember, I get a over 1 minus r. Multiply the numerator and denominator by 5 to clear that fraction. And so you get 3 on top and 4 on the bottom. So that actually equals 3/5, that sum. Excuse me, 3/4. That sum equals 3/4. Now, look at the summation from n equal 1 to infinity of 2 over n. So this is 2 times the summation from n equal 1 to infinity of 1 over n. The summation from n equal 1 to infinity of 1 over n diverges by p series. P equals 1, which is less than or equal to 1. So a constant multiple of a divergent series must also diverge. And so what that says is the summation from n equal 1 to infinity of 2 over n must also diverge. Now, this is what I want to take a look at. I'm going to let S sub n equal the summation from k equal 1 to n of 3 over 5 to the k. What we have shown is that this sequence of partial sums converges to 3/4. And remember, another way to say that is that the limit as n goes to infinity of S sub n is 3/4. Now, here, T sub n is the summation from k equal 1 to n of 2 over k. And what we have shown there is that this sequence diverges. Remember, a series converges if the sequence of partial sums converge. A series diverges if that sequence of partial sums also diverges. And so what that says is, remember, you're adding up positive terms. So if I take the limit as n goes to infinity of that sequence of partial sums, I get infinity. Okay? And so if we notice, that's going to force this sequence to diverge. There's no choice. Or I should say divergence. And remember, S sub n plus T sub n is the summation from k equal 1 to n of 3 over 5 to the k plus 2 over k. So I could do that. When you add up finite sums, I can do it accordingly. You can rearrange terms freely. Everything works well. Okay? And if that sequence of partial sums diverge, then what that means is, by definition, the summation from n equal 1 to infinity of 3 over 5 to the n plus 2 over n must also diverge. I don't know if that makes sense. So I showed that the series of the first term, right? So I took a look at the series of 3 over 5 to the n. I took a look at the series from n equal 1 to infinity of 2 over n. So we got a series that converges. We got a series that diverges. So basically, when you add them, it must diverge. I hope that's okay. And then on 7D, let's take a look at 7D. We have the summation from n equal 1 to infinity of, if you don't mind, I'm going to put 9 over n to the 1.1 minus 7 n to the 1.0001. This one is not as bad as it looks, because I'm going to look at the limit as n goes to infinity of 9 over n to the 1.1 minus 7n to the 1.0001. And this is negative infinity, which doesn't equal 0. And so what that tells me is that the summation from n equal 1 to infinity of 9 over n to the 1.1 minus 7n to the 1.0001 diverges by test for divergence. And that'll do it for this video. And we looked at the Exam 3 review, problems 7B, 7C, and 7D. Thank you.